Hola. Hope everyone's doing well today. I will wait about one more minute and then I'll get started. Man, these dogs are eating really loud this morning. What are you dogs doing? They sound like little piggies. Okay. So I'm going to go ahead and get started. So what we have learned over the past 3 lessons was about the functioning of neural networks, and you guys wrote code for your own neural network. So what we're going to do today is we are going to learn how to use an API that does all the neural network stuff automatically. Okay, so this is a as you can imagine, it's quite easier to do. I wanted you guys to understand the nuts and bolts of how a neural network works, how it operates. But now that you understand, or hopefully you understand it, we can then just use an API that does all the work for us. Okay. So let me show you what that API is called. I think this is, yeah. So this API is called Neuroph. It has, so this is the website. It has a number of tutorials, and it has documentation. So when you go to documentation, it gives you the list of classes and all that stuff. We're not really going to need to use this all that much because the example code that I'm going to give you has pretty much everything that you need in it. You just kind of need to modify my example code. But there's a lot of stuff you can do here, and the stuff you can do goes way beyond my understanding of neural networks. So this is definitely a powerful API. I know there are others as well out there. I think Google has one that is very popular. So if you're interested in this kind of thing, it might be worthwhile to learn Google's API. I want to say it's called TensorFlow or something like that. And I'm sure if you learn that, you would actually be, somewhat put that on your resume, and that could get you hired somewhere. Okay, so that's that. The other thing I wanted to point out is here's the assignment. This assignment, so I already gave you all of the jar files in a zip file, as well as the code I demonstrated in class. So you really just download that, and it has everything. And there are like, I think, 3 or 4. I think there are 4 jar files. Maybe it's 3. I'm trying to count here. 1, 2, 3. 1, 2, 3, 4. So there's like a lot of jar files that you need in order to, and actually the number is different in each case. So I just wrote the complete build and execute commands, and you just copy that into whatever, if you're compiling from the command line or you're compiling from Genie, this is what you're going to type in. Okay, so you can just copy and paste that. All right. So let me show you my code. So first of all, I'll show you the training data. So I want to make this bigger. Just make sure that this is what I want to show. Cool, it is. All right, so this is the training data, and the training data is 150 lines long. So there's 150 examples of plants. So this is what I'm going to do is I'm going to make a neural network that can classify iris plants. So there are 3 types of iris plants. There is Iris setosa. There is Iris versicolor, and there is Iris virginica. Okay, and then there are some numbers. So each line has 4 numbers separated by commas, and then the type of iris that represents. So what are these 4 numbers? Well, I can't remember what they are, but it's something like petal length and petal width and flower size or something like that. It's just 4 parameters, and it doesn't really matter from the perspective of the neural network, but these are all different measurements that were made of individual plants of the Iris setosa type. So if we just look at it, we sort of automatically do what a neural network does. Okay, so if I look at the first column here, first column is like around 5-ish, right? The first column for Iris setosa. But if we look at the first column for versicolor, we can see that it's a little bit bigger than that. It's kind of like, more like 6 or 7. And then if we look at virginica, it's also kind of like 6 or 7. So, if that first number is small, I would probably guess that it's an Iris setosa. If we look at the last number is like 0.2, 0.4 for Iris setosa. For versicolor, it's like 1 point something. And then for Virginica, it's like the high ones into the twos. So, our human brain sort of automatically is really good at classifying things, but we're going to basically teach a computer how to do that. So basically what we're going to do is we're going to feed this data line by line into the neural network, and the neural network is going to adjust its network weights, the weights in the neural network. Those were the W numbers, and to best try and predict what is going to happen, okay, or what type of iris it is. So here's the code. I have a number of import statements. Basically, when I am putting in import statements, I kind of tend to put them in last. So like what I'll do is I'll write the code, and then I'll try to compile it, and it'll give me symbol not found errors. And then as the symbol not found errors come up, I use that to add the import statements. So I'll be like, oh, I need this, forgot to import that, I forgot to import that. So I kind of use the error messages to figure out what I need to import. Okay, so this class is called MyNeuralNetwork2, and I just put the main function, the main method, excuse me. So that's all it is. It's just a main method. So what we're going to do first is we are going to prepare the training data. Oh, I need to make this bigger too, don't I? All right, prepare the training data. So the training data comes in this CSV file, okay? And we can see that it has 4 numbers that represent the measurements of the flower, okay? So the input is 4 numbers, okay? So if we look at it, I can see that I have a data set, training set. It's a new data set, and this first number is the number of numbers in the input, and the output is the number of possible outputs of the neural network. So now why is the number of outputs 3? It's because there were 3 types of irises that we were trying to classify. Okay, there's Virginica, versicolor, and setosa. All right. So that's what I did there. And then I defined some basically some constants. Okay. So the neural network has 3 output nodes, basically. And if the output is 1, 0, 0, that's going to correspond to setosa. If it is 0, 1, 0, that is going to correspond to versicolor. And if it is 0, 0, 1, then that is going to correspond to Virginica. Okay, so these are basically the outputs for each type of flower. And then I also have 0, 0, 0, which is if it doesn't match anything. Okay. So now, so this part of the program, when you guys do the assignment, you are going to change this part of the program because I think that the problem that you are doing, if I remember correctly, has something like 7 different possible outputs. So you're going to change this number to 7. And I think it also has 9 numbers in the input. So, yours is going to be like a 9, 7, your data set, because there's 9 input numbers and 7 output numbers. But don't quote me on that because I can't remember exactly. And then furthermore, you would have to have more constants here. Okay, because I only have 3 because there were 3 types of flowers, but I think you're going to have like 7 different constants there. Then what we have to do, and this is kind of annoying, is we have to read the CSV file and add each line to the training set. Okay, so the first thing I did, and this all has to be within a try-catch block because there could be issues with reading the file. All of this you're going to basically copy in your code, but you're going to just make minor changes. So for example, your file name for your training data is going to be different. Mine is called irisdata.csv, and so this line simply opens up that file and gets it ready to be read. Okay. You could also do this with a scanner, by the way, if you wanted to. And then it says, and then we have a while loop that says, so there's a variable called line, which is a string. So I defined line up here. And so line is a string. And so what we're doing is we're setting line equal to the line that is in the file. So we're reading the lines. So what this loop is doing is it's setting line equal to this, and then it's setting line equal to this, and it's setting line equal to this, and then it's setting line equal to this, and it's just going through the entire thing, each iteration of the loop. It goes through, and it waits until it tries to read the next line and it gets null. And so basically, if it gets all the way to the bottom of the file, it's going to try to read the next line, and there is nothing. And so the next line is going to be null, and then it jumps out of the loop. Okay? So this is just going through the entire file, line by line. And then I'm taking that line, and I'm splitting it at commas. Okay? Why? Because it's a CSV file. What does CSV stand for? It stands for comma separated values. Okay, so so I'm splitting this into an array of strings that has 5 elements in it because there are 5 data points here. Okay, for each iris. So this is a particular iris. So this is going to be a string array with 5 elements in it, and the 0th element, for example, is going to be 6.9. The 1th element is going to be 3.2. The 2nd, 5.7. The 3rd, 2.3, and the 5th is going to be Iris virginica. Okay. So now I'm going to take the input. I'm going to define I defined a variable called input, and I'm going to parse each of these elements of the input array. So now remember, I turned iris into a string array. Okay, but the inputs are really doubles. So I have to turn the string into a double, and so I have double dot parse double, and it's taking the 0th element of iris and turning that into a double. So what is the 0th element of iris, for example, for line 121 in this file? The 0th element would be 6.9. So what this part is doing is it's taking the string 6.9 and it's turning it into the double 6.9. And then it is doing the same thing for iris 1. So it's taking the string 3.2 and turning it into the double 3.2. And then this is taking the next one, 5.7, the string, and turning it into the double set 5.7. And then here I am taking the last 2.3 number and turning that from a string into a double. Okay. Now what you'll notice here is that each of these are divided by something. So this is the 0th element is divided by 8. The 1th element is divided by 4. The 2th element is divided by 7, etc. So why did I do that? Well, what you want to do with neural networks is you always want to scale your inputs so that all the inputs are between 0 and 1. Between -1 and 1, I should say. You can go a little bit bigger than 1, but in general it's good practice to have it between -1 and 1. Okay, so if you look at the input data set, basically what I did is I looked at the first column and I just looked at it and I see that sort of the biggest that the first column gets, like the biggest number I see right here is 7.9. Okay, you see that? So what I'm doing is, because I know the first column, the biggest number is 7.9, I know that if I divide by 8, that's going to make all of the first column numbers less than 1, right? 7.9 divided by 8 is less than 1. And then similarly for the next row, I think I saw that the biggest was 3 point something. Oh, here's one that is 4.2, 4.1. But in general, there's just a couple that have bigger than 4 for the second number, a couple of plants. So I divided that by 4. So this is something that you're going to have to adjust for your own data set, right? Because your data set, the numbers are going to span a different range. So you want to sort of divide by the maximum for that column. Okay? And then for the output, so remember the output is the last line, or the last part of each line in the CSV. And so I said, if the fourth, so for example, if the fourth element or the fourth part of that line, the last part of that line equals iris setosa, then the output should be setosa. If the last part of the line equals versicolor, then the output should be versicolor. If the last part of the line is virginica, then the output should be virginica, and otherwise I just had it be the none output. Okay? So again, if you have 7 different options, then there's going to be 7 different else if statements, right? Okay, and then for each of these input-output pairs, we add it to the training set. And then I have it just print training data added. And I also had it read the lines just because when I was debugging the program, it was getting hung up reading this. And this was actually the hardest part of writing the program, is just getting it to read the CSV. All right. So basically, we just have a big loop that is adding all of the data into a training set. So this is 150 input-output pairs to try and teach the neural network how to identify irises. And then the rest is really easy. So I have a neural network. That's a class that is part of the Neuroph API called MyNN. And the type of neural network that I've taught you about, there's multiple types, is called a multi-layer perceptron. So, this is going to be the same for you. The output, remember how the nodes of the neural network give an output that is the sigmoid function. So that isn't the only output function that you can have. So you have to specify that you want a sigmoid. There are other options, like I think inverse tangent is a good output function. There's various possible output functions, and then you specify sort of the architecture of the neural network. So this is a neural network with 3 layers. Okay. The first layer has 4 neurons. The second layer has 4 neurons, and the third layer has 3 neurons. Okay. So this is a little bit different from the code that you wrote, because the code that you wrote, every single layer has the same number of neurons. Okay, so yours could only be 444, for example, or 444. This would be 4 layers with each. This would be four layers with each layer having 4 neurons. You could do something like this. This would be 5 layers, with the first 4 layers having, 4 neurons each, and then the last layer having 10 neurons. All right. But what is important, okay, is the input layer. This is the first number, has to match the number of inputs for your data set, right? And the output layer has to match the number of output neurons has to match the number of possible outputs that we have. Okay? And then the number of layers and the types of layers in between doesn't really matter. So I could add 2 layers in between. So maybe I could make this 5, like that. So that's a 4 layer. But I found that for this example, it's sufficient to just have 3 layers. Okay. I think for your neural network, because you have more input data, it's going to be advantageous to have more layers. Okay. So then I just have a line of code that says beginning training, and then I call the learn method on the training set, and it just does the training for you. Okay, so that takes some time, but it's my neural network.learn the training set, and then after that's complete, it says training complete. So then what I'm going to do is I'm going to test the neural network. Okay. And so now there's a line that prints to the terminal that says testing trained neural network. And I create an input. It's a new double. And so this means that the first number is 7.3. The second number is 2.8. The third number is 6.2. The fourth number is 2.2. Okay, and I have scaled those, just like I did up here. Okay, so I scaled them by the exact same numbers, otherwise we're going to get have big problems. Okay, so let's try and guess. Looking at the looking at the data, let's try and guess, just using our human brains, what type of iris is this? So this one is, the first number is like 7.3. So the first number is big. All right. So iris setosa has the first number being like less than, less than 6. Versicolor has the first number for the most part in the 5 or 6 range. And Virginica has a lot of irises that have a first number that are in the 7s. Okay? Now let's look at the second number. The second number is 2.8. That's pretty consistent with the range of iris virginica, right? It's kind of like 2.8 to 3.2 or something like that. The third is 6.2. That is pretty consistent with the third line. And the fourth number is 2.2, which is pretty consistent with the last line. So using our human brains, this is probably iris virginica. Okay. But let's see if I can control F. So I'm going to search for 7.3. Okay. Look how it says. Can you see that? I'm trying to make sure if you can see that. Oh, you can't see that window. Okay. But there is no line of code. There's no line in this input file that has 7.3 in this column. Okay. So, in other words, the neural network is not just copying. I'm giving it an input that it wasn't trained with. It wasn't trained with an input that had the first number that is 7.3. None of these irises have a first number that is 7.3. Okay? So what that means is that, but the neural network is still going to be able to classify it. So what the neural network does is it starts to recognize the patterns. Okay? So you can train it with data, and then you can give it new data. Okay? And it will still be able to make the right decision. You can give it data that it has never seen before, and as long as you've trained it properly, it's going to be able to classify that thing. Okay? So then I set the input, and then I calculate the output, and then I get the output, and then I display it. Okay? So let's run it. I already compiled it. And so you can see that it added all 150 lines. It says reading line 150, training data added, and now it's beginning training. So this is the part that takes a while because it has to feed all of that and adjust the weights, and so it gives it an example, adjusts the weights, gives it an example, adjusts the weights, and it just does that a bunch of times. So we have to wait for that. I don't know how long it's going to take. Oh, there it goes. Okay, so now it says it's beginning training. Then it says training complete. Now it says testing trained neural network, and it has the output. So remember, the output is 3 numbers. Okay, and so what we want to do is we want to look at what is the biggest number. So this first number is 10 to the minus 5. See how it says e negative 5? That's a really small number. That's basically 0. The second number is 10 to the minus 6. So that's a really small number, basically 0. The last number is 0.9999999 something. So the last number is basically 1. So these first two numbers are basically 0. The last number is basically 1. Now if we look at which of these is that closest to, this actual output is basically 0, 0, 1. And I can see here is 0, 0, 1 right here, and that corresponds to Virginica. Okay? So what the neural network has done is it has deduced that this is probably, it's very likely to be Virginica. Even though that's not, this data point was not in the training set, but it is able to generalize and take a guess that this is Virginica. All right? So we can try it again with just one more flower type. So let's say I want to make one that's Iris setosa. Okay. So it looks like Iris setosa has a first number that is roughly around 5. So I'm going to make it 4.9. Okay. So what if I make the first input 4.9? Okay. And then for Iris setosa, the second number is maybe let's say it's kind of like mid 3s to, it's kind of like mid 3s, basically, the second number. So I'm going to make it 3.7. The third number is pretty close to 1.5, it looks like. So I'm going to make it 1.2. And the last number is really small. It's like 0.2, 0.3, 0.1, something like that. So I'm going to make it 0.3. Okay, so this is a pretend iris. This iris was not in the training data set, but it should be able to classify it as an Iris setosa. Okay, so let's see what happens. So I'll compile it. Run it. There is a way to train a neural network once and then save the neural network so that you don't have to train it every time you run the program. So you can basically save the neural network to a file, and then so I didn't have the time to sort of delve into that, but it is possible to train it and then save the trained weights of the neural network, essentially. So we're just waiting for this to finish training. Come on, neural network. Boom, 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 boom. We are waiting for the neural network to train. Feels like it's taking longer this time. It's the same training set. Or maybe I just had more to say during the training part. As you can imagine, the larger your training set is, the more time it's going to take to train the neural network. So feel free to do every other line or every third line or something like that, because I think I gave you a huge training set. It's like 10,000 lines. So just keep that in mind. The bigger your training set is, the more time it's going to take to train the network. If you think about humans as a neural network, it takes, 18 years to train that neural network. Even more. My neural network is still being trained. Come on, gosh darn it. I will wait 1 more minute at most. I'm setting a timer for 1 minute. Setting a 1 minute timer. Hey Siri, set a 1 minute timer.
Your timer is set for 1 minute.
So we're going to see if it can finish training in 1 minute. And if it doesn't, we're just going to bag it and go to the Zoom room. I think the program might be hung. You know what? We're going to end this lesson on a cliffhanger, okay? So you're going to have to come to the Zoom room to see the result. All right? So I will see you in the Zoom room, where we will see if the neural network classified it correctly.